Okay, now the action that we just did of finding points in the plane given by certain polar coordinate pairs can be done algebraically as well. So this is converting from an r theta description of a point to an xy description of a point, a Cartesian coordinate pair. So this is actually very easy. Remember our construction, you want to walk counterclockwise theta radians from the x-axis and then move r units away from the origin in that direction. And if we think of the right triangle, xy coordinates labeling these sides right here, the x here could be a negative number, the y could be a negative number, just like on a unit circle, then that's the xy pair representing that point, right? So it turns out that the xy pair for Cartesian coordinates can be found just by solving for the lengths of the sides of the triangle on the unit circle here, okay? So that comes from the definition of cosine and sine. Cosine is defined to be the adjacent side over the hypotenuse, so remember that's x over r. Sine is defined to be the opposite side over the hypotenuse, so y over r. And if we rearrange both of those equations, we get, x is equal to r cosine theta and y is equal to r sine theta. So remember these. These are how you convert from polar to Cartesian coordinates, and you just do that calculation. So that's why it's really easy. So for instance, right here, we're given an r value of 1 and a theta value of minus pi over 3. Okay, so plugging them into my formula there, x is equal to r cosine of theta, means that I'm working with 1 times cosine of minus pi over 3, right? And if you remember properties for computing values of cosine, well, the cosine of a negative angle is the same as the cosine of a positive angle. If I go, instead of theta degrees here, and I go minus theta, that means I'm walking in the reverse direction, but it would still be the same x adjacent side of my triangle length. So that's why this is always possible. So I'm just using property of cosine there. Cosine of minus any angle is cosine of an angle. That's also called property of being an even function. All right, so do you remember your value of cosine in the first quadrant at pi over 3? That's 1/2. Next, we have y to calculate. So it's given as r sine theta, plugging in r equal to 1 and theta equal to minus pi over 3. We also have a similar property. Sine is what we call an odd function. Sine of minus an angle is the same as minus sine of that angle. So this is equal to minus sine of pi over 3, and we can calculate that easily. Do you remember sine of pi over 3? That's one of your first quadrant angles, so you should remember these types. Remember, all of your trig functions can be calculated from sine and cosine, just knowing their values in the first quadrant. So that would be root 3 over 2. So we have minus root 3 over 2 for that guy. And finally, our description in Cartesian coordinates would be the xy pair is 1/2, comma, minus root 3 over 2.